6-1 is basic identities and their use. This is where you're going to start to learn how to verify. Alright, going through this next, this is the basic identities that you've already learned. We learned that in the last section. You have your reciprocal identities here, and then remember that the tangent and the cotangent, everything is a sine or a cosine. And then with your negative identities, that's where we looked at a graph here, just looking in these two sections. And if we went down just a little bit, the sine would stay negative, the cosine would be positive, and the tangent would be negative. Pythagorean theorems is just x squared plus y squared equals r squared for the unit circle. So tangent and those, that's just replacing a few things, dividing by sine squared, or just changing it around a little bit. But you're going to use, the one that you're going to use the most is going to be this one here. Alright, so example 1, it says verify the identity cosine x tangent x is equal to sine x. So first thing you should usually do is change everything to cosine and sine. So I actually have the cosine of x, and remember tangent is sine x over cosine x. You only deal with one side. If you go there, what you can see is that now you can cancel out your cosines, and you're left with sine x equals, and this was our target, equals sine x. It's as simple as that. Verify the next one. Go ahead and try it, and I'll just put the answer for you. Okay, there's the answer. Now going on to this next one, we want to do identity verification here. So what we want to do is we want to take a look at the secant x. Remember that secant x is 1 over the cosine of negative x. Okay, let's go back to our graph here. Remember we're only using these two sides. If we go just a little angle here, in the negative side, your x stays positive, therefore your cosine x is going to stay positive. So what you have now is 1 over the cosine of x, and 1 over the cosine x is equal to 1 over the secant x, which verifies that these two are equal. Okay, the next one is for you to do, so go ahead and pause and try it, and I'll put the answer up for you. Okay, there's the answer. Okay, right here, these are just suggested steps to take. You start with the more complicated side of the identity, whichever one looks like it's really big or has tangent or something like that. And then you want to try to transform it into the simpler side. Try any algebraic operations, multiplying, factoring, combining fractions, whatever it is you can do, or even splitting them up. If other steps fail, express each function in terms of sine and cosine, and then perform the appropriate algebraic operations. And finally, at each step, keep the other side of the identity in mind. Remember, that's your goal. What's going on with the other side of the identity? That's where you want to get. Okay, so here, if we look at the side that looks more difficult, it would be this side here. So what we're going to do is take the cotangent, and cotangent, let's see, tangent is sine over x, so cotangent is cosine x over sine x times the cosine of x plus the sine x. Okay, so what you have is the cosine squared x over sine x plus, and now we've just got the sine x. Well, why not try to combine these by getting common denominators? And our common denominator is simply sine x. So I'm going to multiply both the top and the bottom by sine x, so that I now have the cosine squared x over sine x plus sine squared x over sine x. And now I can combine these. I end up with the cosine squared x plus sine squared x all over sine x. Alright, so something you need to remember, I'm just going to move this over a little bit so I have some more room. Something you need to remember is don't forget that identity that we know, the Pythagorean identity, and remember what cosine squared x plus sine squared x is equal to. That's equal to 1. So we've got 1 over sine x, and 1 over sine x is the same as the cosecant x, and that's what we wanted in the end. We're done. Okay, this is where you get to try it, so you go ahead. I'm going to put down the steps that I use, and then you can compare that way. Okay, there's the answer, and I hope that's the way you went too. Okay, so for example number 4, it looks like this is our more complicated side, and I think the best way to go here is to get a common denominator so we can combine that as 1. So now we've got 1 plus sine x all over the cosine of x, and we want to multiply, oops, wait, let's go ahead and finish that up, plus the cosine of x over 1 plus sine x. And if you look at our denominators, our common denominator is the cosine of x times 1 plus sine x, and whatever you do on the top, you have to do on the bottom as well. 1 plus sine x, and do it to the other side as well. So we've got the cosine, all right, the cosine of x times 1 plus sine x all over the cosine of x times 1 plus sine x. Okay, let's cancel out stuff. So I can cancel out my cosine and my cosine. I can cancel out my 1 plus sine x and 1 plus sine x. What I have left is 1 plus sine x times 1 plus sine x plus the cosine squared x all over cosine x times 1 plus sine x. All right, now obviously if I start canceling out, I'm going to go back to the same spot. So what I want to do is I'm going to go ahead and FOIL this. So foiling that, I get 1 plus 2 sine x plus the sine squared x plus cosine squared x all over cosine x times 1 plus sine x. Okay, notice something. We've got sine squared x and cosine squared x. Sine squared x and cosine squared x is equal to 1, so I've got 1 plus 2 sine x plus 1 all over the cosine of x times 1 plus sine x. All right, let me make this a little bit smaller so I have a little bit more room. So now what I'm going to do is I've actually got 2 plus 2 sine x over the cosine of x and 1 plus sine x. I'm going to use my algebraic my algebraic mind and factor out 2. So I've got 1 plus sine x all over the cosine of x times 1 plus sine x, and now I can cancel these out, and I'm left with 2 over the cosine of x, which is like saying 2 times 1 plus the cosine of x, and if you remember, cosine of x is equal to secant x, so we've got 2 secant x, and that's what we wanted in the end. Okay, here's how I did it. All right, going on to the next identity verification. As we're looking at this next problem, we need to figure out which one are we going to solve. Okay, this one, what you need to think about is sine squared x as x squared plus 2x plus 1. All right, so what we can do is factor it, and then don't forget that we can change our cosine squared x plus sine squared x equals 1 just by subtracting the sine squared x from both sides. And now you've got the cosine squared x is equal to 1 minus the sine squared x. So that's this right here is what we're going to use. Okay, so let's go through and do that. So I've got the sine squared x plus 2 sine x plus 1 all over 1 minus sine squared x. Okay, this is like x squared plus 2x plus 1, and this is like 1 minus x squared. So we're just going to factor them. So if I factor the top, I've got sine x plus 1, sine x plus 1, over, and if I factor the bottom, I've got 1 minus sine x, 1 plus sine x. So now what you can do, 1 plus sine x and sine x plus 1, that's like saying the same thing, so you can cancel those out because addition is commutative. You can switch it around, and so now we might as well just switch this one around too and make them look the same, and we have our final answer. 1 plus sine x all over 1 minus sine x. Done. All right, it's your turn, so go ahead and pause and I'll solve it out and you can see how you did. Okay, here's the answer. The trick about this one was to remember that secant squared x is equal to tangent squared x plus 1. So I just replaced my secant squared x's with tangent squared x plus 1. Okay, these problems get a little tricky. So if you think about for A, you think about, let's say, x equals the pi over 4. So I've got the tangent of pi over 4 plus 1, and I've got the secant of pi over 4, and then the cosine of pi over 4 minus the sine of pi over 4. Tangent of pi over 4, don't forget your triangle, is 1 square root of 2 for a 45-degree angle. So the tangent is going to be the opposite over the adjacent plus 1. And the secant I like to think as 1 over cosine. Cosine is adjacent over hypotenuse, which gives you 1 over the square root of 2, but we're going to flip it. So the square root of 2 times the cosine, which is adjacent over hypotenuse, minus the sine of pi over 4, which is going to be opposite over adjacent. So what you have here is 0. So we've got 2 equals 0. Square root of 2 is 0. So it doesn't work. Let me show you a trick. I want you to take a look at this graph. This graph is the graph on where I have said that y1 is equal to tangent x plus 1 and y2 is equal to secant x times cosine of x minus the sine of x. They don't coincide. Because they don't coincide, they don't work. So now I want you to see for the next one, for B, so I'm going to shrink this real quick. Alright, so that went with A, and now for B. This is the graph of B, and what I said was that y1 is equal to the tangent of x minus 1 and y2 equals a secant of x times sine x minus cosine x. This is the trick. If they are the same graph, you know that they verify. All right, here's your homework. Good luck. I know you're going to be successful.